We work for Microsoft in the area of cloud security. Today we are here to talk about how to improve your organization's cloud security posture. So let me quickly take you through the agenda for today. So we're going to start with introduction to cloud computing. We'll talk about what cloud computing is and what are the services that it offers. And we are going to compare how security is different in cloud from the on-premise environment. And we are specifically going to talk about certain areas like identity, access control, data security, monitoring within cloud. And for each of these areas, we are going to see some of the practical scenarios that customers face in their journey to the cloud. And we'll follow it up with potential solutions to address each of these challenges. And we are going to talk about what is the best solution for the customers to quickly adopt to these new and emerging challenges in the cloud. And we'll have a dedicated time for Q&A towards the end. But in case you guys have any questions where you want to stop us before we move to the next slide, simply raise your hand and we'll be there. Over to you.
So, just to do a quick survey, how many of you work on cloud technologies on a day-to-day basis? By a show of hands, please. Okay, a couple of you. I'll expand the audience a little bit more. How many of you are familiar with cloud technology? You've not worked with it directly, but you're familiar with what that might be. So, okay, that's a large number of people. That's great. So, let me give you an example. Say, me and a couple of my friends, we got together and started an e-commerce startup. And as part of that, we're setting up an application server, and right now it's working out of my garage just as a desktop. Now I start getting a lot of customers, and I need to scale the size of my application server. And so what do? I can scale it up to, say, maybe adding a couple more servers, still managing my own infrastructure. But as I go forward, my company takes off. And that means I need to scale up. There are a couple of options here. One option would be I go ahead and buy more infrastructure, manage it on my own, and take care of all the costs. The other could be I just rent it from a third-party provider. He takes onus of everything from the maintenance costs, making sure it's up and running and things like that. So, simply speaking, cloud computing is when a third party will deliver on-demand resources on a pay-as-you-use basis. Why do customers move to the cloud? As I mentioned, it's on-demand, and there is the matter of a self-service portal. So the cloud solution provider will give you a self-service portal, and you can just go with just a few button clicks, provision and configure all these resources. The second would be cost. So I'm reducing the amount of money I spend on electricity, making sure the servers are cool, making sure it's all up and running, the IT admin costs, etc. I'm reducing all those costs. The third one would be, depending on my needs. So let's say my e-commerce site is seeing a massive boom because it's New Year's and people are buying a lot of gifts to send to each other. And now, for this very short period of time, I can just increase the number of instances, which is a scale out, or increase the amount of compute that my system has, which is a scale up. Just for that period of time, and I will pay some extra money just for like those 2-3 weeks around New Year's, and then I can scale back down. The fourth one would be performance. When we say performance, that's actually referring to the cloud solution providers ensuring that you have the latest and the greatest hardware running on the cloud infrastructure. So you don't have to worry about upgrading and updating those. The last one is reliability. What does reliability mean? So reliability refers to the SLA based availability, which means the cloud solution provider is actually guaranteeing a certain amount of uptime, and they will back this guarantee. And in some cases it's financially backed, and you can claim damages as well. Before we start, some of you might be familiar with some of these terms, but let's just go over these one time so that we're all on the same page, because we'll be repeating these terms over and over during the course of our session. What do I mean by on-premise? anything that me and my friends host in my garage, or maybe in another room or another building, but that's owned and taken care of by us. That's our infrastructure. What is a cloud solution provider or cloud vendors, and we'll use these terms interchangeably. So that's any third party. That could be Google, could be AWS, could be IBM, could be Microsoft, and they are going to own the cloud infrastructure that we're talking about. The third one is public cloud, and the key thing that you need to remember about the concept of public cloud is that you can connect to the cloud over the internet. The fourth one is cloud customers. So cloud customers would be companies like the example I gave, my e-commerce site, or it could be any of your companies that will adopt the cloud. The last one is resources. So resources is any service, any web application, any web server, database that you configure and provision on the cloud, that's a resource. In terms of subscription, so subscription, are you guys familiar with what a cloud subscription means? Show of hands. Okay, so I'll just quickly run through that. When I go to a cloud solution provider, asking him for their cloud services, they will provide me a subscription which can be accessed through an online portal, cloud management portal you can call it, and that subscription gets mapped to a certain login ID and password. And so those credentials are what I will use to log into the cloud management portal and access my subscription. My subscription is the boundary within which I will have to configure all these resources. When I say resources, all the cloud services that you provision will be within that subscription. Some cloud providers also give you the capability to segregate the resources that you set up for production environment as well as dev and test, because let's say I want to have a different kind of access control and management for the production environment. For dev and test, I will just let everybody do whatever they want. For the session, we will consider a fictional insurance company called Iceman Insurance, and let's take a look at what their cloud adoption journey has been like and some of the challenges they're facing. Hearing some feedback. Okay. So let's talk about scenario number 1. Now, Iceman Insurance is a company with about 50,000 employees, and currently they are looking at migrating their payroll application to the cloud. Now, all of these employees have to access that payroll application, right? So the app development team for the payroll application comes back and asks, how should I be authenticating all these 50,000 users on the cloud? Because as it stands today, I'm using something called an on-premise directory service, say for example Active Directory, to use the corporate credentials for my 50,000 employees to log into this application. Now when I move this entire infrastructure to the cloud, how should I authenticate? So let's take a look at that.
This is one of the very initial problems that most of the customers face when they decide to move their infrastructure to the cloud, right? Let's say you're a startup company that does not have any infrastructure in the on-premise world because you have just started the company. For them, it's easy to start their journey directly in the cloud, create your identities in the cloud. So when I say identities, I mean your employees' user IDs and passwords and all the details about your employees, which you can later on use for authentication as well, right? So if everything stays in the cloud, so identities as well as the applications, you can simply leverage the identity solution which is in the cloud and let your users log into the applications in a secure way. But if you are a traditional company or if you are an established enterprise who has already invested a lot of amount in the on-premise infrastructure and in your own private data centers, for you to move to cloud, you will have to first figure out the problem of identity. How do you manage the identities? Because all of your infrastructure or the identity, at least the identity solutions are in the on-premise network, and now you move one of the applications and host it in a cloud. How do you log into that application? Because my authentication server and the details are in the on-premise world. So this is the problem that most of the companies initially face. So let's take a step back and talk about how on-premise authentication works. And then we can figure out how we can have an equivalent solution in the cloud. So we all access applications within our office network or the private network. And we are able to log into these applications seamlessly. So have you ever thought about how this authentication works? Anyone? How does somebody log into applications, or for that matter, let's say, how does someone or an employee log into his workstation when he is in office? What is the authentication that happens in the background? Anyone?
You can take a guess. It's okay. We're all friends here.
Okay, so what happens in most of the on-premise network scenarios is that you have a directory service, which is most often an active directory, which will hold all the information about your employees, starting from the user IDs to their passwords, to their designations, to their email IDs, to their phone numbers. Everything is maintained in one single server, which is called as a directory service. And whenever you try to log into your machines or access applications, you try to enter the corporate credentials, and these credentials are validated against the identity server, which is in the same network. The crucial point here is that because it's in the same network, I can manage this authentication process seamlessly. And through leveraging this sort of an identity model, from several years we were able to provide secure, reliable, robust solutions within the on-premise network. But the apprehension is that if I move to cloud, will I get equivalent security in the cloud? Will there be any security challenges for me? Or can my employees, do my employees now need to enter new credentials in order to access the cloud applications? That's the primary concern. So we have a couple of solutions to address this problem. Let's talk about the first one, which is called the managed identity solution. So what happens in this is that you create another directory service in the cloud, and you synchronize all of your details which are present in the on-prem directory or the active directory into the cloud. So once this happens, all the details, including the password hashes of the employees, will move into the cloud. And once directory service in the cloud is aware of all the details, you can directly leverage the directory service in the cloud in order to authenticate your employees. You don't have to talk to the on-prem active directory as such, because both the applications and identities are in the same space. Whereas the other solution, which is called the federated identity model, for some reason, let's say you don't want to move your employee password hashes outside of your network. What is the solution that we have? It's the federated model. So in the federated model, what happens is you have to initially set up a federation service within your on-premise network. So this will be an internet-facing server, which means anyone from internet can come and talk to it. And at the same time, you will create a directory service within the cloud. Next one, please. As you can see, even here you are going to create a directory service, but this directory service will not have any information about your employees' password hashes. It will just know the user details, meaning it will have information on the list of users, but it doesn't have password hashes. But what we are going to do is we are going to establish a federation trust between both the on-premise as well as the cloud directory services. And now let's think of a situation where an employee is trying to log into that. He enters his corporate credentials. Initially, the application redirects back to the federation server. Because the federation server can talk to the active directory, it can validate the credentials. If those credentials are valid, it will issue a token, and the token will be carried back to the application, and then it will be given to the directory service in the cloud. But how does my directory service in the cloud know whether it is a valid token or not? Because this token has been issued by a different directory sitting somewhere in the on-premise network. It knows that it's a valid token or not because there is a federation trust that is established between them. Which means if I sign a particular token and issue it, the other server can determine whether it is signed by me and whether it is valid or not. So this way, without moving the employee password hashes out of your network, you can still achieve equivalent authentication if you want to log your users into the applications. If you compare both of these solutions, it's up to the enterprises to determine which one works best for them. But the first one, the managed identity solution, has less maintenance because once you sync your details into the cloud, you don't have to maintain any extra infrastructure in your own on-premise. So it's sort of simple and also simple and easy to maintain. Whereas in the federated model, because you are hosting your own federation server in your network, you will have to ensure that it has high availability at all points of time. Because remember that if your federation server is down for some reason, it means that your employees will not be able to sign into these applications. Whereas in the cloud scenario, your cloud provider will give you assurance that it will be available for 99 or 99.9% of the time. And the last point of comparison is the password hashes. So if you have any security compliance reasons because of which you will not be able to move this information out of your network, in that case, federation server will be the best solution for you. With that, let's move to a different problem that Iceman is now facing.
So now we understand how can Iceman manage the identities. So after this, there are multiple teams within Iceman Insurance that decide to go ahead and migrate to the cloud. So as you can see, there's multiple applications, and all these application teams are going ahead and provisioning their resources in their cloud subscription. What happens now? So at some point in time, you will start having a lot of databases, you'll have a lot of API servers, you'll have a lot of web servers, and all that might just become a lot of confusion. Now the IT admin for Iceman Insurance has a challenge, and they want to figure out who can I identify who's the person that's creating these resources, who has access to these resources, and who's doing what with these resources. So let's talk about how are they going to solve this problem.
So this brings us to the problem of access control in the cloud. With cloud, granting access to someone to control a resource is pretty simple. You just log into the portal, click few buttons, you will have the permission, or you'll be able to give the permission. So it's not only about giving the permission, it is also about understanding what are different levels of access controls that somebody can have in cloud. For instance, I can have access at a resource level, meaning maybe to control a database, or maybe to deploy an application, or maybe to read data within my database, right? And you can also have access at resource group level. What is a resource group in cloud? It's pretty simple to understand. You group a bunch of resources into one group, that becomes a resource group. So Iceman's payroll team, for instance, can group all of their resources, and they can call it payroll resource group. So all my infrastructure will be in one logical group. So somebody can have access at a resource group level, which means he will be able to control all the resources under it. The last one is the subscription level. As Sukriti mentioned in the initial slides, subscription is the boundary in the cloud. So everything is within a subscription, including the resources and the resource groups. So if somebody has access at subscription level, he is going to control everything, starting from a resource to all the resource groups. So those are different levels of access that somebody can have. So before we jump into the solution, we need to understand a concept called RBAC, because cloud providers extensively leverage the RBAC model in order to solve the problem of access control. What is RBAC? RBAC is a role-based access control model which is used to perform certain authorization mechanism. RBAC is not new to computer security. It has been there for quite some time. We are only leveraging the concept in cloud. So RBAC is all about giving authorization or giving the access at a very fine-grained level. So what does fine-grained exactly mean? It means that you're going to give the permission to a particular employee the minimum level of permission that he needs to accomplish a task. For instance, let's say I am in an administrator team and my job is to access the logs and move them to a different location. So my permission should only be at the logs level, to read the logs. It should not be at the entire database level where I can connect to the database, read the data, or add some details to the database. There are three important concepts within RBAC that we need to understand. The first thing is the concept of a role. So any action that you perform on a resource is sort of a privilege that you have. Let's say you connect to database to read, so you have a read access. You connect to database to write data to it, so you have a write access. So role is basically a set of privileges that somebody has on a particular resource. The second thing is the scope. As we discussed in point number 2 about the boundaries, we need to have a scope for the access. You can be a reader, but can you read all the databases in your resource group? Can you read all the databases in your subscription? No. So scope is all about defining what is the access control boundary for you. And the third thing is the role assignment. Remember, all our identities are now in the cloud, and cloud knows the list of users that are going to log into the applications or going to access the resources. So once we have identities and roles set up in the cloud, access control in cloud simply reduces to the activity of assigning roles to these identities. I don't have to go and give special privileges to everyone. I can just map these roles, and if I want to revoke an access, I can just simply remove the role. Next slide. So let's look at how RBAC works in real time. Let us say a particular user has issued a request, couple of requests, one to a particular database to read the data, and two to a different database to delete the data. What are the list of things that cloud environment does before executing these? The first thing, it verifies what is this guy's role. He's trying to read a particular column from the data. So does he have the reader role? Second thing, it tries to determine what is the role, what is the scope of this particular person. He might have read access, but does he have access to read this particular resource? It determines the scope. Once these two are determined, it's a matter of either allowing the access or denying the access. So in the first case, let's say the user has legitimate access to that database, it will be processed. If it is in the second case where he's trying to delete someone else's database, the access will not be provided, it will be simply denied. So let's quickly talk about key things to remember in terms of access control. So understand what kind of access control features your cloud provider offers, because not every cloud provider is going to offer the same level of access control mechanisms. Second thing, RBAC is only an offering by the cloud provider. It will not be of any use until the customer actually spends some time to figure out what is the level of access that I need to give, what is the minimum level of access that my employees need, and accordingly go and map the role. So the onus is also on customer to do that effort and accordingly map these roles. And the third thing is the case of privileged accounts. So privileged accounts are those accounts which have, access to highly sensitive environments or highly risk environments where you are gathering lots of sensitive data. For these sort of administrative access, make sure that you track these separately to see what is the kind of access these people have and do they really require it. And on a periodic basis, you need to revise and see if their access is justified. And the last interesting thing is about the just-in-time access. You can think of this concept as similar to the web application, cookie validity sort of thing, where once you log into an application, you will be given a cookie, which will be valid only for a certain period of time. The same concept is being applied in terms of administrative actions. Let's say I need to connect to a remote server to do some administrative function. I will have the privilege to do this only for, let's say, 5 hours or 8 hours. And after the expiration of that time, my access will be automatically revoked. So with this, we are going to limit the exposure of privilege. So even if an attacker gets access to my credentials out of this privilege time, he will still not be able to connect to my resource to do any of the harmful things.
So just before we move on to the third one, are you guys following? Any questions? Still awake? Okay. So now we've looked at what are the identity problems that and how they overcame them. We looked at how they can manage the access control problem. Now Iceman has to look at a different problem. They are worried about the data security. So as we mentioned right in the beginning, they're an insurance company, right? What do insurance companies do? You file claims with them. And so as part of those claims, their customers will disclose different kinds of sensitive data, things like medical history, things like family's medical history, things like payment information, could be social security numbers. And now they want to make sure that they can secure this data. So their privacy analyst comes up with the question that we have all of these sensitive information stored in our databases. How can we make sure that the cloud solution provider cannot read these? How can we make sure that if there's an investigative agency that comes to the cloud solution provider, even then they can't read the data that we have? Or for instance, for some reason, if there is a data breach with the cloud provider that I'm storing my data with, even then I don't want the hackers to get to my data. So what do? Let's take a look.
Perhaps this is one of the most controversial and most debated topics when it comes to the cloud, right? What happens to my data? And is my data secure in cloud? So we all know that the problem to data security, the solution to the data security problem is to store the information in an encrypted fashion, right? And do cloud vendors encrypt the data when they store it in the cloud? Of course, all of them do. Then what do you think is the problem? When the data is already being encrypted and stored in the cloud, what is the problem? So with any encryption, it finally boils down to the question of who is holding the key. Because whoever holds the key will be able to decrypt the information if he has the encrypted text in his control. So most of the offerings that cloud vendors by default have are those where they encrypt the data and the key also stays with the cloud provider. So we need very secure mechanisms to solve this problem of key storage and key access, and how does this whole thing work. So we are going to talk about something called hardware security modules, or HSMs as we call. So HSMs are crypto processors which can store keys within them. And the main important point when it comes to HSM is that once you place a key in a HSM, you will not be able to extract the key outside of the HSM. Not even the owner will be able to extract the key outside the HSM. But then what will HSM do then? It can perform cryptographic operations, meaning you can send data to HSM. It can use the key which is present inside the HSM and give you the encrypted text back. Or you can send the encrypted text to the HSM. It can decrypt it for you and give you the plain text back. But the key never leaves the system. The key is always inside. So that's one thing to understand. And the second important thing or the concept to understand here is something called the bring your own key. I think most of you might have heard about this. So bring your own key is an offering where you can bring your own keys into the cloud and you can encrypt, or you can use those keys to encrypt the data that you store in the cloud. So together with these two concepts, we will be able to solve the problem of data security, and let's see how. Let's go back to the same scenario, to the customer, to the Iceman customers entering sensitive information like medical information, for instance. So once they enter their medical information, it will reach the insurance application, and insurance application then needs to figure out what are these sensitive fields that need to encrypt, and those fields directly flow into the hardware security module. And the HSM will then encrypt it and send back the encrypted text. Remember that the key is still in HSM. Nobody has access to it. We send the plain text and we got the encrypted text, which can now go and sit directly in the cloud. So everything that's in the cloud is encrypted with the key which is in my control. So the best part of this whole thing is that you can save or you can create these HSMs within your on-premise network, or you can create them within the cloud. So if you're already having HSM which you're using in an on-premise network, you can simply extend it into the cloud or use any of the key service that any of the cloud provider offers. So don't be confused, because even if the cloud provider himself is offering a HSM, because of the very nature of the concept or the concept of HSM, he will not be able to gain access to the keys. Let's quickly go through the important things to remember. First one is that although your data is stored in cloud, you can still retain your control using bring your own key and using the concept of hardware security modules. And not just encryption keys, you can identify all of the secrets that your application uses, for instance like database connection strings or API keys or even the certificates that you use for authentication purpose. All of these can be moved to one single key store or a key store which is backed by HSM. The third thing is this HSM should not be accessed directly by any of the employees or any of the users, because there is no reason to do so unless you have some complex business case. So there should only be programmatic access to read or to use these HSMs. And remember, keys cannot be extracted out of HSMs, but that doesn't mean they cannot be deleted. So if I can delete a key which is placed in HSM, then all of your data which is encrypted in the cloud becomes junk, because without the key I won't be able to decrypt it, right? So make sure that you have very tight policies around who can control these key stores and who can update or delete the keys within these key stores. And the last thing is, once you start using these cloud-hosted key services, you also get other benefits. Like now that you have all of your keys at one single place, you can define key rotation policies on top of it. You can have proper versioning system for it. You can read the access logs with respect to each of these key stores. So make sure that you leverage all of these features when you're using any of the key stores. So with that, let's move to a different problem now.
So that's great. Now they've decided that they want to move all their applications to the cloud, but because of the nature of the size of data, they have a sales and marketing application, and there is a really large amount of data in the sales database. So at one point, they have migrated all of their infrastructure except for the sales database from on-premise, and the network admin wants to make sure that the on-premise resources or the database should be able to securely connect with the database as well as the API servers, the web application that's hosted in the cloud. And so we want to find out how can we securely make that connection. Let's take a look at that. And yeah, thank you.
So migrating IT systems is not an easy task. It's going to be very complex, and with the more infrastructure, the problem becomes even more complex. So companies do not move their infrastructure overnight to cloud. They're going to do it in phases so that they can test the waters and they can decide for themselves whether the cloud is working for them and if they should move the rest of the infrastructure. So there will be cases or multiple cases where some of their infrastructure still lies in the on-premise and some of their infrastructure has moved to cloud. And now both of these resources need to interact with each other. So how do I do this? So this is the problem that network teams face, for instance, in terms of implementing these connections. And the need to access these resources as if they are in the same environment arises because that is how we have built all our infrastructure over the years, right? So in pursuit of achieving these connectivity, there are a lot of things that can go wrong. For instance, in the same Iceman's case, assume that the network admin takes the on-premise database and exposes it to internet so that the traffic can come directly to the database and somebody in cloud can talk to the database. But databases are never to be exposed openly to the internet or to any of the outside world. So that can lead to attacks such as brute force attacks or a lot of other attacks. So insecure hybrid deployments can often lead to critical security gaps. So you need to have a proper strategy in case you want to connect your on-prem resources to the cloud resources. And before we jump into the solution, I'll just spend 30 seconds to talk about what are virtual networks within cloud. So think of them as a network boundary. You create a network boundary and you add resources to that network boundary. Now all of these resources can talk internally among themselves. They can talk privately. So if one resource needs to talk to another resource, it doesn't have to come over internet. It can just ping each other using their local or private addresses. So you can create virtual networks, as many virtual networks as you want in the cloud. Now let's go to the solution part and see what are the couple of solutions that we have. The first thing is the virtual private network gateway connectivity. So what happens as part of the solution is you need to install or you need to set up a VPN server or a VPN gateway within the on-premise environment, and the cloud provider himself will have another gateway on his side, and you connect both of these gateways using a site-to-site VPN. So I guess some of you might be using VPN to access your network from your laptop, right? So that's a point-to-site VPN. In this case, since we are connecting a virtual network in cloud to the on-premise network, this becomes a site-to-site VPN. And once this connectivity is established by your network team, all these resources can talk to each other privately, as if they are in the same network, just like intranet scenario. Whereas the other solution involves establishing a dedicated connection between the cloud network and the on-premise network. So they take advantage of internet service providers who will actually come and physically connect both of these using dedicated networks, which means the communication that is happening between these two is not over internet. It's a completely private network. Nobody has access to that network. So if we quickly compare both of these scenarios. So the first thing is about the traffic, right? So in first case, the traffic still goes over internet, over IPsec protocol. Of course, it is an encrypted connection, but it still goes on within the internet. And the second, whereas in the other case, it does not go over internet. It's a very dedicated route. And because this is a dedicated route, it supports higher bandwidths. So in case your production workloads are mission critical, for instance, think of a stock exchange website where you have no scope for failure, then it will make sense to go with this sort of a setup which guarantees more availability and more bandwidth for the connectivity.
So that's great. So now we've tackled 4 of these challenges, and now Iceman Insurance has decided to move all of their infrastructure to the cloud. Now, their security team comes back and has questions around my security monitoring and alerting systems are right now on premise, and all of these systems do not connect or obtain the monitoring and security alerts from the cloud infrastructure. So now, how can I fix this problem? How do I solve this challenge? Let's take a look.
So a lot of established companies already have dedicated security teams that monitor the network and the host layer to identify attacks such as brute force attacks or malware which is spreading across the network, or some sort of anomalies in the traffic. Maybe there is huge amount of traffic which is being moved from the on-premise to the outside world, so that triggers an alert. So they do monitor for these kind of attacks and scenarios within the on-premise world, and they often use tools such as SIEM, which stands for Security Incident and Event Management, to collate or to gather all of these alerts which are coming from different systems across the network at one single place, and on top of that I can write my own rules which will trigger the alerts, right? Whereas in the cloud, you do not even have access to any of the network to scan the network to start with, because most of the underlying infrastructure is owned by the cloud service provider. So the question of how do I monitor for security incidents and events in cloud is a very valid question. And remember, these tools that we use within the on-premise network, they don't have any out-of-box solutions to say, I can monitor cloud and give you the alerts, right? So we are going to see how this will be addressed. And another important point to remember here is that the threat landscape in cloud is very different from the on-premise network. For instance, let's say one of the credentials of your on-premise workstation are compromised. Now, can somebody directly connect to your machine? No. He needs to be in the network initially, and then he can exploit it. Whereas in the cloud, if there is a virtual machine that is public-facing, gets its credentials compromised, I can sit at my home and connect to the virtual machine and control it. So we need to understand that the threats are emerging within the cloud, and they are very much different from the traditional attacks and the traditional incidents that we used to witness in the on-premise world. And security monitoring teams also need to evolve their strategy in terms of covering these new attacks with respect to the cloud. So the solution for these kind of scenarios is identify cloud providers who provide out-of-box security alerts as part of their offering. So not everyone does this. So before you switch to a solution, just find out how are the security alerts shown within the cloud. For instance, the screenshot here shows various different attacks or events that are generated within the cloud. So you can see for compute, for networking, for storage and data, and for applications, And the cloud provider, most importantly, is able to show this information to you because he has access to the underlying core infrastructure. So he can do a lot of things that you cannot. And he generates this for you and gives it to you. And you can also sort it by severe issues or critical issues across all the applications. And so how do you monitor them once they show the alerts, right? So there are a couple of things you can do. One is to monitor these completely from the cloud. So you can just log into their security centers and you can see all of these, monitor directly from there. Or you can bring all of these alerts back to the monitoring systems that you have within the on-premise network. So there are options to integrate the solutions. For instance, you can bring those alerts into your own SIEM solution. So once you do this, you will have one single view where you can see all the alerts which are related to on-premise as well as which are related to the cloud. And make sure that you leverage the custom rules feature as well. Custom rules feature is where you define certain alerts which you think are specific to your applications or specific to your business case scenarios. And you can define these alerts and you can integrate them back to your monitoring solutions as well.
So let's do a quick recap. We talked about identity. So you as a company needs to make sure that you identify what's the right identity management solution for you and what is the way you want to configure it. The second one we talked about was access control. And that means you ensure you implement role-based access properly in the cloud, leverage the capabilities that are provided by the cloud solution provider. The third one is the data security. So leverage the concept of bring your own keys along with the cloud HSMs. So when I say HSMs, there were two options. Does anybody remember what the two options were? So one was that the HSM could be your on-premise HSM and the other could be the cloud solution provider's HSM. And you can pick either of these choices and see what suits you best. The third one was hybrid connectivity. So how do you ensure that all your resources which are on-premise connect securely to the cloud infrastructure that you have in place? There are multiple ways, as we discussed. Pop quiz. Yes, site to site was one. What was the other one? There was a dedicated. Thank you so much. You guys are paying attention. The fifth one was tap into security alerts. So you have the monitoring systems on-premise already in place. You can either use the monitoring systems that the cloud solution provider gives, and there's a dashboard that they'll provide. You can take a look at that dashboard, or you can feed all the information from that dashboard into your on-premise security systems, security monitoring systems, and identify and take care of those security alerts. Questions? Yes, please.
How would CSP and those customers deal with ransomware, and how would attacks like ransomware, and how would they provide us suitable solution to their customers?
Right, so let me take that question. So the question is, how do CSPs deal with ransomware attacks? If there were ransomware attacks which are spreading within the virtual machine network in a cloud, how do they operate? So there are two ways of solving this problem. One is that, remember the connectivity, where we connected the resources which are running in the cloud to the on-premise. So if you have your systems interconnected, where you have virtual machines running in cloud which are joined to your domains within the on-premise network, and within your on-premise, if you're having a policy to verify for such kind of ransomware attacks, you will be covered. That's number one. But let's say you're not covered, you don't have any connectivity and your virtual machines are running in isolation within the cloud. Then what next? So cloud providers do have this technology, at least when it came to WannaCry ransomware situation. Cloud providers did give updates with respect to which machines are affected, because a lot of these machines, remember, are public facing. So they do have information on what is the underlying operating system that is running in the virtual machine. So whether you are infected or not, even without that information, they were still able to provide that since you are running on this virtual machine with this particular operating system, you will be vulnerable to WannaCry software. Does that help? Yeah. Yes?
Can DC be considered considered as a private cloud for the users?
DC
Data center.
can be considered as.
Cloud computing for the users, general users? Can that be?
So when you say data center, you mean the one that your company will host within?
Yeah.
That is your private cloud, yes.
Can you consider that?
Consider for?
Private cloud.
That is private cloud. So private cloud could be provided by third party, or if me as a company is hosting my own infrastructure, that is my private data center or private cloud.
So in your point, you said that you require the internet for considering private cloud, but within the organization, we don't provide the internet. I mean,
Public. Public cloud is the only, public cloud is what you will access through the internet.
So for public cloud, we need internet. But on your speech, might be my mistake. I heard that internet is required for cloud. That's why.
Okay, so when we say cloud, we are generally talking about
Sorry,
the public cloud.
yeah.
Yeah.
Sorry about that.
Any other questions? Yeah.
So like does CSP and do they like uses unbots and observable security measures to deal with other attacks like DOS and which would like affect the data?
Yeah.
So how would they like deal with that?
So they will not be offering solutions such as honeypots out of box to the customer. But what they can assure you is, they can assure you, for instance, that your application will not be susceptible to DDoS attacks, like the distributed denial of service attacks. Because they have other software and other analytics, like cloud is very big, right? So they have a lot of analytics and intelligence to figure out whether a particular server is being attacked from multiple places and all of that. So they assure you from distributed denial of service attacks and so on, but they don't offer you out-of-box honeypot kind of scenarios.
They also, so we talked about the security learning and monitoring, right? That's for your application infrastructure. Cloud solution providers also have their own. So they will monitor their underlying infrastructure for some of these attacks that you mentioned. And they publish this information publicly available. Any other questions? We'll be around if you guys want to ask us any questions afterwards. Otherwise, we can wrap up.
Yeah.
Thank you so much.
And on behalf of Sukriti and myself, I would like to thank ThreadCon team for
Yes, thank you so much.
having given us this opportunity.